All right, ladies and gentlemen, welcome back to our final video with Unit 6 in thermochemistry, which is going to focus in on Hess's Law. Now, this is going to correspond to section 5.6 in our textbook, so please go reference that, read over that to make sure that you have a good idea of some of the other extensions. It does have other problems that are worked out that you can look through, and it can just give you a deeper understanding because I'm going to be hitting the high points here. So without further ado, let's hit our last section so we can be done with thermochemistry. That's exciting. All right, here we go. So Hess's Law, what is it? We've been looking at reactions. We've understood that we can look at an individual step and it's going to have an energy change that's going to be associated with it, right? It's going to release or absorb a certain amount of energy. And for chemical reactions, the enthalpy of a given chemical reaction is constant. And what we mean by that is it doesn't matter if we get to the products by one step or many steps, right? So if that's the case, if we have a chemical reaction that gets us, which yields us the same reactants and products, then if it's carried out over multiple steps, then what we should be able to do is that we should be able to take that many-step process, add up the enthalpy changes for each of those steps, and it should add up to the enthalpy change that we calculated for maybe if it was a one-step. And so Hess's Law essentially takes advantage of this idea of carrying out a reaction in a series of steps and adding those enthalpy changes together. Now you might be thinking, well, Mr. Kent, why is that possible again? And it goes back to understand that enthalpy is a state function. It doesn't matter how many steps it takes for the reaction to get to the products. All that matters is what did I start with and what did I end with, right? And so the path that we take to get there is not so important here. It's only the final and initial states of our process. So that being the backdrop, here are some things that we need to keep in mind as we're using Hess's Law. The first thing, just like in our kinetics unit, when we're looking at mechanisms and things like that, one thing that we had to have is that whatever reaction we're trying to get, the sum of your steps better make up your target equation, right? So if you've got a series of steps, the reactants and products that you get from those series of steps need to match up with the overall process that you're trying to measure. Okay. Point number 2. If you're given a step and you need to reverse a reaction in order to get to your overall target equation, because you might have to do that, then what you're going to do is when you flip the reaction, the value of delta H will stay the same, so the magnitude stays the same, but the sign will flip. So if it was an endothermic process to begin with, you flip it, it's now going to be exothermic. Likewise, if it started off as an exothermic process and you flip it, it's going to become endothermic. Okay. And then the third thing we need to keep in mind, if for any reason, as you're moving around and you're trying to get your target equation to match up, or your sum of steps to match up with your target equation, you may need to multiply by some coefficient. Now, if you have to do that, what you're going to need to do is you're going to need to multiply that particular step by that coefficient, which means you need to do the same thing to the delta H value for that particular step as well, but only for the step that you're having to multiply. You don't have to do it for the entire 3-step process. You just look at each individual step and see what you need to do. Okay, so those are 3 really big things. Your multiple steps need to add up to the target equation. If you reverse a process, flip the sign of delta H. And if you need to change coefficients by multiplying, whatever you multiplied by, do the same thing to the delta H value. Okay. Now, let's look at this particular example. So we already saw this particular process, right? We saw this reaction previously, and we said that it released around 2,220 kilojoules per mole. Well, instead of saying it happened in a 1-step process, let's say that it happened in 3 steps. let's say that the first step is the decomposition of propane. The second is the formation of carbon dioxide. And the third one's the formation of water. And so you got each of those reactions that are present there. You know, what you can do is you've got the decomposition of the propane. So this particular one, that one's good. You've got the formation of carbon dioxide, and then you got the formation of water. You add those three steps together. Notice how your carbons cancel out. You add the equations together, and it's going to give us our net equation here. But what you notice, carbon cancels, the hydrogens cancel, right? You've got your 1C3H8. You've got 3 and 2 oxygens, which if we're adding all this together, that's where the 5 comes from. You've got your 3 carbon dioxides, and you've got your 4 CO2s, or your 4 H2Os, excuse me. Okay. Now, in Hess's Law problems, one thing that they might do is they might give you your steps, and they'll give you the delta H values. And essentially for each of these, they just essentially made this one based on enthalpies of formation. So all you would need to do is you would need to look up the standard enthalpy of formation for each of those substances and then multiply them by the appropriate coefficients, right? And really it is that easy. You add your steps together. You reverse signs if you need to. In this particular case, we didn't need to flip anything. The only thing we'd have to do is we'd have to multiply the enthalpies of formation of carbon dioxide and water by 3 and 4 respectively, and we should be able to get roughly the same answer we calculated previously. And so, ladies and gentlemen, that's Hess's Law, and that's the end of this particular unit. I hope this was helpful. Hopefully that gives you an idea of what you need to do. Please don't forget to work on the practice problems that are associated with this unit. That'll give you a good idea of to kind of check your understanding. So thank you so much for watching this. Let me know if you have any questions. I look forward to seeing you guys again soon. Take care.